Okay, welcome to video 6.3. Here we're going to be talking about exponential growth. So we're still using this y equals ab to the x power, where a is the initial value. So that's like your population, your number, etc., whatever you're starting off with. B is the growth or decay factor. So that's what we're multiplying by. And then b will either be 1 plus the rate if it's a growth or 1 minus the rate if it's a decay. So recall to turn a percent to a rate, move the decimal place to the left twice. So if, for example, we were talking about 50%, well, 50%, that doesn't really have a decimal, but remember we can write it as 50.0 or just point with a decimal point there, then it'll have one. Then if we take that decimal place, we could move it to the left 2 places, which would then make it 0.5 or 0.50, which makes sense since half is the 0.5 or 50%. Okay, and the x usually refers to time, unless otherwise stated. Okay, so now knowing all this, let's look at an example. So if we read through, the population of the country of Oz was 600,000 in the year 2010. The population is expected to grow by a factor of 5% annually. The annual food supply for Oz is currently sufficient for 700,000 people and is increasing at a rate which will supply food for an additional 10,000 people per year. Then they want us to write a formula to model the population of Oz and figure out if our formula is linear or exponential. Well, if I'm looking at the population of Oz and it has an amount that it started at, the 600,000 in 2010, and then it said that it's expected to grow by a factor of 5%. Whenever I see that factor and the 5%, that tells me that it is an exponential because it has this rate here. This is going to be multiplied. And we need to write the equation for it. So since I just decided it's exponential, I'm going to write down at the top here y equals ab to the x power. And then for this specific situation, I'm going to start with y equals because it's a function, y equals. And then if I look at the initial population here, that was the 600,000, so that's what's going to go in place of my a value. And then the rate, well, this is where it's a little bit different. I can't just put in that factor like we've done in the past ones because now it's growth. So it's not multiplied by 0.05%. That would actually be a decay, and that doesn't make sense because they said that it's growing. So in order to do this, I have to look up here in my directions where it said b will either be 1 plus the rate for a growth or 1 minus the rate for a decay. Since this is a growth, it's definitely going to be the 1 plus. So 1 plus, and then we have to fill it in with the rate. But I can't put the 5% in there. That doesn't make sense. So off to the side over here, I'm going to say, okay, well, they had 5%. But I can't put that into my formula, so I'm going to have to change it to a decimal. So that's going to have to be the 0.05. And I got that by looking at where my decimal place was, and which would be after the 5, and moving it 2 places to the left, and then filling that in with a 0. So that's where that came from. So now I can put that next to the 1 plus. And I can just leave it to the x power because they didn't tell me anything about finding out, in a certain year or anything like that. They just wanted the formula, and they want to know if it's linear or exponential. Well, I'm going to say that the function is exponential. And that's because the situation has a common ratio. And then our next problem says that we need to write a formula to model the food supply and figure out if that one is linear or exponential. If I look back, it said that the annual food supply is currently sufficient for 700,000 people and is increasing at a rate which will supply food for an additional 10,000 people per year. Well, 10,000 per year, that's another 10,000 every single year. So I don't think that that's a rate. That's saying that it's going to increase that amount every single year. So I'm going to write that as y equals the 700,000, which was the amount that we started off with, plus 10,000 x, 10,000 per year. So this function is linear because the situation has a common difference or a constant rate of change or a slope. Okay, so that's it for this video. We'll do this more tomorrow. Have a good evening.